Travel with us on a voyage through our solar system. We will be guided by the astonishing discoveries of our interplanetary spacecraft and accompanied by the music of our group. Join us. The title of our performance is Waves. This evocative word captures the essence of our study of science and art. The waves of light captured by our telescopes and cameras bring these images to us tonight. The physical phenomena of waves occur over and over in such disparate settings as the sand dunes of Mars, the rings of Saturn, and the frozen ridges of the distant ice worlds of the solar system. Finally, waves of plucked strings, vibrating membranes, and air in flutes brings you the music in our performance. The outer solar system, beyond the orbit of Mars, far from the Sun, is dominated by cold worlds, with surface temperatures hundreds of degrees below freezing. The larger worlds are gaseous, with thick atmospheres of hydrogen, helium, ammonia, and methane. The smaller worlds are ice worlds, largely composed of our familiar ice, but at temperatures over 200 degrees colder than we ever see on Earth. This year is truly the year of the ice worlds. In the last 12 months, we've achieved a set of breathtaking milestones in our exploration of these small members of our solar system. As witnessed by the stunning picture of Saturn's moon, Titan, eclipsing the Sun, its sunlit atmosphere forming a vivid ring with Saturn's rings in the background. We have completed our first close-up examination of Pluto, the dwarf planet at the edge of our solar system. Pluto is 2/3 the size of the Earth's moon. The New Horizons spacecraft, a robotic vehicle about the size of a grand piano, was in flight for 9.5 years on a sprint out to this distant body. With no means to stop, it flew through the system of Pluto and its moons in a few hours, but it has completely changed our knowledge of this icy world. From New Horizons pictures and data, we can see that Pluto is a geologically active world. There are craters, but also signs of volcanoes that have heated the icy surface. And melted it, producing a series of glacial flows, as shown in these remarkable pictures. Pluto also has a bright heart-shaped feature, the size of Texas, apparently a large flow of nitrogen ice. For a few years, during its 248-year revolution around the Sun, the ices on Pluto's surface vaporize to form a thin atmosphere, which freezes out for the remainder of its long seasonal cycle. For the first time, we've been able to see Pluto's night side with its hazy atmosphere. Almost 1,000,000 times thinner than the Earth's atmosphere, illuminated from behind by the sun. Pluto is surrounded by 5 moons. The largest, Charon, has its own complex geological history. This enormous crater near its north pole is a record of a past impact almost powerful enough to destroy the moon completely. Charon has its own Grand Canyon running along its equator, probably a result of the same impact. In the last year, NASA has started to plan the first exploratory mission to Europa, a moon of Jupiter. First seen through Galileo's telescope, Europa is a world a little smaller than the Earth's moon. Its fractured and cracked surface is very likely evidence for a vast underground ocean. Tides raised by Jupiter flex Europa so that its surface ripples up and down by hundreds of feet every few days. This surging motion produces a great deal of frictional heat. That heat, in turn, melts ice to form a global ocean below Europa's surface. We believe that Europa's ocean is bigger in volume than all of the water in the Earth's oceans. There's one catch. This ocean might be as deep as 20 miles under Europa's surface. How can we be sure that it's there? The new Europa spacecraft will carry a powerful radar with the ability to send pulses of energy that could reveal and then map this curious inverted ocean. Perhaps in time, we might develop robotic submarines that might sail this new sea after having melted their way down through Europa's icy crust. The most distant members of our solar system are the comets. Some of these small icy worlds have eccentric orbits, bringing them close enough to the Sun to vaporize and release long, wispy tails of water vapor and dust. These comets have been observed throughout history by many peoples and cultures, and in earlier times often seen as harbingers of fateful events. In the last year, we have successfully placed a spacecraft in orbit around an icy comet and landed a vehicle on the surface of that comet. As we speak, these two spacecraft are sending back scientific data on the comet as it passes close to the Sun, evaporating tons of water vapor from its surface every second. It turns out that comets are irregular chunks of ice, typically the size of a major city. As they turn end over end in the bright sunlight of the inner solar system, they spray plumes of water vapor in all directions, just like a lawn sprinkler. Chunks of dusty material come off the comet's surface too. Some of this, from comets that have long evaporated completely, is the origin of the shooting stars that we often see in the night sky. We have placed a spacecraft in orbit around Ceres, the largest of the asteroids between Mars and Jupiter. 1/2 of the volume of this object is ice, overlain by a dark, rocky surface layer. Ceres is 1/3 the size of the Earth's moon. Close up, we can see the geological history of a world dominated by a mixture of ice and rock. In some places, impacts of meteorites have revealed fresh, icy material. In others, movement in the ice itself has built up peculiar, isolated mountains. All of these worlds cast a mirror on the geology and chemistry of our own Earth, allowing us to see our own world as one example among a multiplicity of planets, not just now in our own solar system, but also orbiting many of the stars in our sky. Galileo saw strange features around Saturn, but could not identify them through his small telescope. Were they moons, high mountains, a misshapen, non-spherical planet? Thanks to detailed exploration of the Saturn system by the Voyager and Cassini spacecraft, we have an enormously improved view. Now we know. The rings are a vast system of icy fragments orbiting Saturn. On this scale, the Sun, the Earth would appear the size of a blueberry on a dinner plate. The rings are tens of thousands of miles wide, yet only a mile or so thick. Perhaps they are the remains of a moon that never formed. Shaped by Saturn's gravity and the gravity of its many moons, the ring particles create a complex dance around the planet. In general, the inner parts of the rings move faster than the outer parts.